Hello everyone and welcome to the module number 2, lesson number 1, which is packages. In this lesson, we are going to learn the topics about defining and importing packages, introduction to packages, uses of packages, advantages of using a package, categories of packages, built-in packages, user-defined packages in detail, how to create a package and run a program in a conventional way, and the process for creating a package in Eclipse IDE. We'll also look at a demo program for usage of package. We'll look at the rules for creating a package and the naming convention of packages. Also, naming of packages and exceptions, sub-packages in Java, how to import packages, what is import keyword and its details, different ways of importing the packages, about static import, how to import the packages with the static import, the unnamed package or the default package details, packages and the access specifiers in context of packages, and also we'll have a recap of the points that we have to remember. Let us learn now what a package is. A package is a group of related types, as we can say, that can be classes, interfaces, enumerations, annotations, and any other things that is a related type, which will provide access protection and the namespace management. So what is a namespace? Before we talk about namespace management, a namespace will uniquely define or identify a set of names so that there is no ambiguity when objects having different origins but the same names are mixed together. For example, if you have a class of students which contain two people with the same name, there can be ambiguity while calling them. Instead, if you differentiate them with their last names or the surnames, it will be clear that they belong to different families or they are two different people. Similarly, namespace will make things differently identified, removing the ambiguity. And packages are providing an option to give a namespace management in an overview. We can also mention a package as a container of the group of related classes. Here, some of the classes are accessible as they are exposed, while others are kept for internal purposes. Conceptually, we can think of packages as being similar to different folders on a computer. We might keep the HTML pages in one folder, images in other folder, and scripts or applications in another folder. Software written in Java programming language can be composed of hundreds or even thousands of individual classes. So organizing them by placing related classes and interfaces into a specific package will make things easier for us. What are the uses of packages? Programmers typically use packages to organize the classes that belong to the same category or for providing similar functionality. Packages are also used for letting a mechanism to encapsulate a group of classes, subpackages and interfaces, preventing the naming conflicts. For example, there can be two classes with the name employee in two packages, something like college.staff.admin.employee and college.staff.teaching.employee, where the college.staff.admin is the package and college.staff.teaching is also another package, and they can be differentiated with the packages as I mentioned. Making the searching or locating and using of classes, interfaces, enumerations and annotations will be easier. Providing controlled access, protected and default members in the same package have package level access control. A protected member is accessible by all classes in the same package and also accessible to the subclasses located in other package of this class. However, a default member without any access specifier is accessible by classes in the same package only. So when you use a package, it will make access protection based on the access specifier that we will be giving. What are the advantages of using a package? we'll have a better reusability of different classes and other things when we use packages. There is a consistency in using, or there is a consistency in maintaining of classes or other things when you are using packages. It is easy for us to locate the files when you use packages. They serve a way of avoiding namespace collisions. They serve a good purpose in maintainability because it is easy to maintain as we categorize the classes and interfaces and other structures into different packages. They provide access protection when we use packages. Let us look at the categories of packages. We have two types: built-in packages, which are existing Java packages which are predefined in Java, something like java.lang, java.util, etc. We also have something called a user-defined package, which are created by the users to categorize the different classes, interfaces and the related types to store and use for a particular purpose. So if you look at the Java built-in packages, the Java platform provides an enormous class library, which is a set of packages suitable for use in the applications. This library is also known as Application Programming Interface, or simply called an API. Look at the diagram which shows a basic detail of the inbuilt packages of Java, but not all of them. We have Java, under which we have lang package, util package, IO package, net and AWT package shown in the figure. Let us have a brief overview of the built-in packages in Java. Java's inbuilt packages represent the tasks that most commonly are associated with any general purpose programming. For example, a string object contains state and behavior for character strings. A file object allows a programmer to easily create, delete, inspect, compare or modify a file on the file system. A socket object allows for the creation and use of network sockets. Various GUI objects or control buttons and checkboxes and anything else related to the graphical user interfaces can be used. Some of the commonly used inbuilt packages are java.lang, which contains the language support classes. Example, classes which define primitive data types, math, operations and all. This package is automatically imported into all programs without we specifically writing the import statement. The java.io package, which contains classes for supporting the input or output operations, reading the files, writing onto the console or onto the file or anything. Then java.util package, which contains the utility classes which implement data structures like linked list, dictionary, array list and all. And also the support for date or time operations. Then we have java.applet package, which contains the classes for creating the applets. We have java.awt package, which contain classes for implementing the components for a graphical user interface like buttons, menus, etc. We have java.net package, which contain classes for supporting the networking operations. There are literally thousands of classes to choose from the inbuilt packages. This allows us, the programmers, to focus on the design of our particular application rather than the infrastructure that we require to make it work. The Java Platform API specification contains the complete listing for all the packages, interfaces, classes, fields and methods supplied by the Java Standard Edition platform. The below URL contains an exhaustive list of packages and classes which are built into the Java platform. Just load the above URL into your browser and bookmark it. As a programmer, it will become your single most important piece of reference documentation. Let us now look at the user-defined packages. These are the packages that are defined by the user. Here, we first create a directory for the package. Then, we create the classes inside the directory with the first statement being the package name. How do we create a package? Create a package in Java is quite easy. If we do it conventionally without using any IDE like Eclipse, we simply include a package command followed by name of the package as the first statement in the Java source file. The syntax is package space the package name followed by a semicolon. Example, package space demo semicolon, where demo is the package name. In this package, I have the following class, public class employee, in which I will write the statements and code for that class. This will create the package called demo, and the Java uses file system directory to store a package. For example, the dot class for any class you define to be part of demo package must be stored into this directory called the demo directory. Let us look at how to create a package and run a program in a conventional way. To create a package in a conventional way, you have to create a directory under the current working development directory, the JDK bin directory, and we should name it as a demo folder. Then compile the source file from the place where it is stored, for example on the desktop, using the javac command. This will generate a .class file. Now move the file into the directory that we have created under the JDK bin folder. Execute the program from the JDK bin directory with the java run command followed by the package name dot the class name. Note that if we are using an Eclipse IDE, we can create the package just like a folder and add a class we are trying to make use of. It will automatically contain the package statement. Also, the IDE itself will take care of the .class file directory creation and maintaining it. Let us look at the process for creating a package in the Eclipse IDE. Create a new project through the File, New, Java Project path in the Eclipse IDE. You can also go through the Package Explorer, where you can right click and use the File, New, Java Project option. Then a new pop-up window will open. We have to enter the below details: project name, location to save the project, select an execution JRE, select the layout project option, and the finish button should be clicked. Now to create a package in the newly created project, right click on the source folder or the SRC folder and select new package and name that package. A new pop-up window will open where you have to name the package. Enter the name of the package and click on the finish button. Then create a new Java class under the new package that we created by right clicking on the package and then selecting new class. Name the class as my class. Your Eclipse IDE should look like the image that I have projected. When you click on the class, a pop-up window will open. We have to enter the details as name of the class and click on the finish button. Okay, this is how it looks like after creating the class. The package name is automatically added as the first line, though we have not typed anything based on the package structure. Let us look at a sample program for usage of Java packages. The program starts with the package statement, package, demo package, in which I have my class book. I have two instance variables, book name and author, which are strings, and I have a constructor in which I am taking two parameters, string B and string C. These two parameters, B and C, I am assigning to the instance variables using the statements this dot book name equals to B and this dot author equals to C. Then I have a method called public void show, where I am printing the book name and author values of the instance variables using the print statement. Finally, I have the public class test, in which I am writing the public static void main, where I am creating a variable for my book class using book bk equals to new book, and I am passing the two parameters to the constructor Java Herbert. Then I am calling the method show using the bk.show. This class book can be accessed in any of the classes within the same package called the demo package. We have a few rules for creating a package. Let us look at them. Choose a name for the package and include a package statement along with that name at the top of every source file that contains the classes, interfaces, enumerations, etc. to be included in the package. The package statement should be the first line in the source file. There can be only one package statement in each source file, and it applies to all types in the file. If a package statement is not used, then all the source files will be placed in the current default package. That means there is something called a default package into which all the unnamed packaged files will be placed into, which cannot be referred with a distinct name in any other package. There is a convention for naming packages also, like all other identifiers like the variables or the classes or interfaces. Let us look at those conventions. Package names are to be written in all lowercase to avoid conflict with the names of classes or interfaces. Companies usually use their reversed internet domain name to begin their package names. For example, com.example.mypackage for a package named mypackage will be created by a programmer at the example.com. Name collisions that will occur within a single company need to be handled by convention within that company, perhaps by including the region or the project name after the company name. For example, com.example.region.mypackage. Packages in the Java language begin with a java dot or javax dot. We may have a few exceptions in all cases, and in practicality we will definitely encounter exceptions in companies while naming the things. So in some cases the internet domain name may not be a valid package name. This can occur if the domain name contains a special character or a Java keyword. In this event, the suggested convention is to add an underscore, which is represented in the matrix given below. How to legalize the package names. For example, if the domain name contains hyphenated name.example.org, that can be changed or converted into package name prefix like org.example.hyphenated underscore name. If it is like example.int, then we can make it into int underscore dot example. If it contains something like 123 name.example.com, then we can convert it into com.example._123 name. The next concept that we will be going to look at is the subpackages. A subpackage is a package inside another package. It should be created to categorize the package further. If you want to divide something even more categorically under a specific thing, then we will use the subpackages. If you look at the Java main packages and subpackages, where Java is the main Java package, under which we have the subpackage called lang util awt, under which we have the classes system.class, string.class from the lang subpackage, arraylist.class, map.class under the util package, and button.class under the awt subpackage. Sun Microsystem has defined a package name called the Java. This one contains many classes like the system, string, reader, writer, socket, etc. These classes represent a particular group. Example, reader and writer classes are for input-output operation. Socket and server socket classes are for networking, and so on. So what Sun has categorized is, they want to subcategorize these things in the Java package into subpackages like the lang, net, IO, etc. And they have put the input-output related classes into IO package, server and server socket classes into net package, and so on. So once we have seen the naming conventions and exceptions and the subpackage concept, let us go through the concept of importing the packages. Importing of packages is done using the import keyword. If a class has to use another class of the same package, then the package name does not need to be imported separately. Classes in the same package will find each other without any special syntax. Here is an example. A class boss is added to the payroll package, and the payroll package already contains another class called the employee. The boss class can then refer to the employee class without using the payroll prefix. Let's look at the code. Package payroll, under which I have the public class boss, inside which I am writing my method public void pay employee, where I am taking a parameter of the employee class object employee e, and I am writing e.mailCheck method. which means I am calling the mail check method from the employee class, and I have not written anything like payroll dot or other package name dot employee. Instead, I am directly calling the employee class in my class boss. I am able to do this because boss and employee class both are in the same package. Let us look at the condition that what happens if the employee class is not in the payroll package. Then the boss class must use one of the following techniques for referring to a class in the different package. The fully qualified name of the class can be used, for example, payroll.employee, or the package name can be imported using the import keyword and the wildcard, like import payroll.star, or the class itself can be imported using the import keyword. Example, import payroll.employee. Note that a class file can contain any number of import statements. The import statements must appear after the package statement and before the class declaration only. Let us look at each of the technique that we just discussed in detail using the import keyword. How to access a member of a package from another package? The solution is to use an import statement and get the package or the class in it that we want to use. The import keyword is used to import built-in and user-defined packages into your source file. Your class can then refer to a class that is in another package by directly using that name. We already discussed about three types: import package.star, import package name.class name, and the fully qualified name. These are the three techniques. Let us look at them in detail along with examples. Let us discuss the first one as using the fully qualified name. This is an acceptable or legal solution but is not considered to be a good practice. When we use a fully qualified name, then only the declared class of this package will be accessible. Then there is no need to use the import statement, but you need to use fully qualified name every time when accessing the class or the interface. We will usually use the fully qualified name when two packages have the same class name. For example, java.util and java.sql packages contain date class, which is with the same name in both the packages. So when we use the date class, we will write something like this. Example, class myDate extends java.util.date, and inside those class statements we will write. The other example is com.mypackage1.mypackage2 my new class equals to new com.mypackage1.mypackage2. In the first example, we were determining that we are using the date class from the java.util package only, and in the second example we are specifically mentioning that we are using the class from the package com.mypackage1.mypackage2. Writing the fully qualified name during coding is very time consuming, so we don't usually use this method. Note that when we import a package, all the classes and interfaces and other things of that package only will be imported, excluding the classes and interfaces or any other structures of the sub packages, which means sub packages in total will not be imported. Hence, we need to import the sub packages separately whenever that is required. Now let us look at the second technique, importing the only class that you want to use with the package name dot the class name. If you import package dot class name, then only the declared class of the package will be accessible. Example is import java.util.date and writing class myDate extends date, and we will write the statements inside the class. Example 2 is package mypackage1 import com.package2.mypackage2 class, and we write class myClass inside mypackage2 class space my new class equals to new mypackage2 class, which means we are using the class called mypackage2 class from the package 2. Following, we will write our statements that are required. Now the third technique, importing all the classes from the particular package using the package name dot star or the asterisk mark. Example is import java dot util dot asterisk and then followed by our class declaration class myDate extends date and the statements inside. The second example is import com.mypackage1.star. Note that when we use asterisk or the star mark, only the classes inside the package referred are imported and not the classes in the sub package. Now let us look at the next concept, importing the packages and using the static import option. What is the static import? Static import is a feature that expands the capabilities of the import keyword. It is usually used to import static member of a class. Static members are referred in association with its class name outside the class. Using the static import, it is possible to refer to the static member directly without using its class name. There are two general forms of static import. The first form of static import statement, import only a single static member of a class. Syntax, import static package dot class name dot static member name. Example, import static java.lang.math.square root. Here we are importing the static method square root of the math class. The second form of static import statement is import all the static members of a class. Syntax, import static package dot class type name dot star. Example, import static java.lang.math.star. Here we will import all the static members of the math class. Let us look at some example code. Example 1. Public class test, in which I have the public static void main, where I am printing system.out.println math.square root of 144 and I will get the output 12. The next example is import static java.lang.math.star and inside the public class test I am writing my public static void main, where I am printing the statement again using the system.out.println square root of 144, which will again give me the output 12. Note that the import statement is always kept after the package statement. Example, package mypack and then we will have the import java.util.star. Note that if you are not creating any package, then the import statement will be the first statement of your Java source file. Let us look at the last concept under the package called the unnamed package or the default package. If you do not use a package declaration in your source file, your class will end up in an unnamed package, also called the default package. Classes in an unnamed package cannot be imported by classes in any other package. The official Java tutorial advises against this practice in the below words. Generally speaking, an unnamed package is only for small or temporary applications or when you are just beginning the development process. Otherwise, classes and interfaces belong in named packages. If you look at the accessibility of packages with access specifiers, a matrix in which there is a tabulation I have given for it. Private is accessible only inside the class. Default or with no modifier package access is accessible only in the same package. Protected things are accessible by subclasses outside the package and accessible by the code in the same package. Public, accessible anywhere, even outside the package also. The class is accessible and can be inherited by the subclasses also. Let us have a recap of all the important points that we have gone through in brief. At most, only one package declaration can appear in a source file. The package declaration must be the first statement in a source file unit. Every class is part of some package. If no package is specified, the classes in the file go to a special unnamed package, the same unnamed package for all the files. All classes or interfaces in a file are part of the same package. Multiple files can specify the same package name. We can access public classes in another named package using package name.classname.